5, 4, 3, 2, 1.
Hello, and welcome to the BrainSpace Software YouTube learning channel called Brainwaves. This new channel will provide you with access to a series of videos focused on BrainSpace demonstrations and how-to training videos. In this video, I will demonstrate how to create a continuous multimodal learning, or CMML, classifier, CAML for short. In BrainSpace, we refer to a single predictive model as a classifier. CAML, or CMML, is a workflow that leverages the powerful supervised machine learning capabilities of BrainSpace. The CMML workflow can be carried out entirely in BrainSpace and integrates supervised learning with BrainSpace's new tagging feature. CAML can also be used with our relativity integration to prioritize documents for linear review based on a predictive rank. This CAML to relativity workflow can also be fully automated. With CAML, predictive models may simultaneously be trained for as many binary classifications as desired. Training can be done using batches as in predictive coding, or in a more flexible fashion, by tagging documents anywhere they are viewed. Predictive models may be used to rank documents within BrainSpace, and top ranked documents may be selected for training. All the training data selection methods provided in the predictive coding workflow may also be used. Predictive scores may be exported to a review platform. The CAML approach is similar to CAL and TAR 2.0, but goes beyond those approaches in terms of ease of use, effectiveness, and the ability to leverage BrainSpace's wide range of analytics to find training data. Now let's begin the demonstration. Okay, to create a CAML classifier, we'll first need to create a tag. To create a tag, we'll go to the administration section of the application. And next to the data set that we want to create a classifier for, we're going to click on the tag icon. Here, we're going to click on New Tag and give our new tag a name. This can be any name. And we're actually going to create a single choice tag for this demonstration. And the choices are going to be responsive and non-responsive. To keep it simple, we'll save our new tag. And you can see our new tag here in the list of available tags. You also see the count, the number of documents that have been tagged with that field or tag and those choices. Since we just created this tag, you'll notice that they're all zeros, so we have no documents currently tagged with our new tag and choices. We'll go ahead and close the tag management screen. And now we're ready to build our classifier. We'll need to launch the data set by clicking on the data set icon. And typically when you build a CAML classifier, you're looking for some exemplar documents. You want to use all of visual analytics to get to a subset of exemplar documents that you can then use for training purposes. So we'll start by running a concept search for LJM, and this is the Enron data set. And the LJM is a special purpose entity created by Andrew Fastow. It was part of the Enron scandal. If we start off creating running a search for LJM and then looking at the related concepts or the expanded concepts that come back, we can decide that a term like Raptor might be important and make that a required keyword search. And now we've gone from 1 million documents to about 2,300 documents. We can then switch over to the dashboard, and from a structured data or metadata standpoint, can we filter down this 2,300 documents even further? And we may do that by looking at, the volume of data based on email sent date. We can say that 2000 has more data than the other years. We can then look from a entity standpoint or other metadata standpoint. We could filter down the data set. But let's switch over to the COM analysis, and let's see if there are specific individuals that we can target as part of this investigation or ECA exercise. And here we can see Sarah Shackleton and Mary Cook are the two biggest players. They have the most volume of communication as it relates to LJM and Raptor. Their nodes are the largest here on the graph. We can confirm that by clicking on one of those individuals and seeing the level of participation and the level of communication that's being sent and received by this individual. And we can also click on the edge between those two individuals and retrieve those specific communications. So now we're looking at about 140 documents, all related to LJM and Raptor, all specifically associated with both Mary Cook and Sarah Shackleton. So at this point, I could say these are really good examples of what I'm looking for in terms of my ECA or in terms of an investigation. And now I want to tag these documents so that I can build a camel classifier to train using these documents as good examples. And to bulk tag these documents, I'll simply use the tag results icon. I'll search for my newly created tag and I'll mark them responsive. You can see down at the bottom, those documents are getting tagged. And now I'll switch over to the classification tab. And this is where you'll build your classifiers. Now, just a reminder, we have two specific workflows around classification. We've got CAML, or continuous multimodal learning. And we also have a traditional predictive coding workflow, but we're only going to talk about the CAML workflow in this particular video. So I'm going to create a new classification or a new classifier, and I'm going to give it a name. And in this case, I'll name it so that it matches the tag that I created to keep things simple. Again, you have two specific workflow types. We're going to create a CAML classifier and use the CAML workflow in this example. So I've given my classifier a name. I've selected CAML as my workflow type. Click on Next Validation Steps. And here you can see the CAML classifier is asking for the positive category for the tag that you're going to associate with this classifier. So there is a one-to-one relationship between a classifier and a tag. So every classifier needs a tag. And so we're going to use the newly created tag LJM Raptor, and our positive category is going to be the responsive. So positive meaning what is it you're looking for? So I'm looking for the responsive documents, and notice it's telling me that I've coded 140, which you recall from the communication analysis screen, we did code 140 documents as responsive. And for the negative category, obviously that's going to be the non-responsive. And notice that I don't have any documents currently tagged in the negative category or non-responsive choice, and that's okay. It's not required. One of the great things about CAML is you don't even need a minimum number of documents to build a classifier. I could start training with a single document. If I have a really good sort of key document, I can use that really good example to train my classifier. So there's no minimum number of documents required to train a classifier. The system also does not require any negative examples to start training. Now, obviously, as you begin to train the model and you iterate through the training process, you're going to organically come across good negative examples, and you're going to want to train on those as well. But we can start with 0 negative examples. So I'm going to save my newly created classifier. And now I'm ready to train. It's that simple. I've given my classifier a name. I've associated it to a tag in the specific positive and negative categories. It's telling me here that I've coded 140 documents. And I simply click Train Now to begin training the classifier. And in about 30 seconds, it's going to learn about the 140 positive examples, and it's going to assign a predictive rank to the remaining documents that have not been tagged. So that's about a little over 1 million. This is the total population in your data set minus the 140 documents. So it's going to assign a predictive rank to all of the documents here, and then it's going to resort these documents based on that newly assigned predictive rank, so that the highest ranking document, and now it's finished, so you can see the highest ranking document here will rise to the very top of the pile. And if you quickly kind of look at the subject of these messages or documents, titles of the documents, you'll see that a lot of them are referring to Raptor. That would make sense. You also see that we graph out this is an interactive chart, but we graph out all the predictive ranks for the 1 million+ documents in this data set. And you can see that there are a lot of highly ranked documents. You can see the score there, 0.96, 0.95, and then there's a huge drop off in the rank. And you can use this graph, you can interact with it to say, only show me documents over a certain rank. And let me look at those first. Let me look at the really highly ranked stuff first, and let's see if I've got any false positives. Let's see if I've got any documents showing up as highly ranked or highly likely to be responsive that are actually non-responsive. And so I could trim this graph to cut down what I'm looking at, and I could start at the top, open up the first document, look at it, and remember, these are documents that have not yet been tagged. So this is everything minus the 140 that you tagged to run the first training round. So just starting at the top of the pile, based on predictive rank, this is supposed to be the highest ranking document. I can confirm responsive or non-responsive. So using the same tag that I've associated to the classifier, I can stamp or confirm, yes, this is indeed responsive. And as I stamp the document, confirming responsive, non-responsive, it's automatically flipping to the next document in my list. So you can quickly go through at a glance, looking at the document and confirm responsiveness. And you can do that for any number of documents. You can decide, look, I'm going to look at the top 20. I'm going to make some decisions, responsive, non-responsive, and then I'm going to use those 20 examples as a second training round to retrain the classifier. Because the idea here is you want to get those, you want to make sure that the predictive rank is as accurate as possible. Because you're using that rank so that what is likely to be responsive rises to the top of this very large pile of documents. And from an investigative standpoint, you're really just trying to find that needle in the haystack. You're trying to find the facts around a particular accusation or an event that occurred. And once you find those facts, once you have enough information, you can stop training the model. So it's all about getting to the facts of a case as quickly as possible. And we help you do that in this very lightweight supervised machine learning workflow. So we're just forcing things to, forcing things that are likely to be responsive based on your examples as a subject matter expert, forcing those documents, those good examples, to rise to the top of this very big pile. And so you can take that approach. You can just start at the top. You can work your way down the list. Um, After you start perhaps seeing some consecutive non-responsive documents at the top of the pile, you may want to stop at that point and retrain the model so that those non-responsive documents get pushed to the bottom and your likely to be responsive gets pushed to the top. So you're basically playing with the sort order and the predictive rank. And you can continue to do that in this very efficient, very flexible way of training a model. So I can, now that I've coded another 6 documents, one negative and several positive, I can retrain the system uh, on those new decisions that I've made. I can also create a validation set. So if at any point I want to make sure I'm not missing anything, and you can create a validation set and have the system go out into those areas of your data that you haven't seen yet, that you haven't perhaps coded yet, that have unique vocabulary or unique content that you haven't come across yet, and you can feed those in as a second or subsequent training round, and thereby sort of ensuring that you've got great examples across your entire data set to make sure that you're not missing anything that's likely to be responsive. And you can also use this graph here to keep track of sort of where you're at in terms of training your camel classifier. Ideally, what's happening here is this is based on the number of documents you're reviewing and how many of those documents are likely to be positive or responsive documents. And as this line continues to rise, that means you're reviewing more documents and you're still finding more positive examples or more responsive documents. So as long as this line is rising, you want to continue to train your model until you've either gotten to the facts of your case, if it's an investigation, or if you're going to use these predictive ranks to prioritize review for larger litigation type cases, then you want to keep track of this line. And as this line starts to level out over 2 or 3 training rounds, what you're going to see there is you're reviewing more documents, but you're not finding any more positive or responsive examples. So when this line begins to flatten out over several training rounds, it's a good indication that you've sort of, in terms of your predictive rank, you've reached the optimal predictive rank for each and every document in your data set, that the ranks aren't really changing. You're not finding any more positive examples. your model's got some stability, and you can decide at that point, depending on whether it's an investigation or a litigation, that you can stop training the model. You can also use the highly ranked documents from a training round and build a focus. So you think about building a focus for things that are likely responsive. So anything over a certain score, for example, in this particular example, uh, I took any document that had a predictive rank of 0.75 to 0.99, and I built a cluster wheel or a focus off of that subset of data. And what we're doing here is showing you all the themes around all of your likely to be responsive documents. And you can use this to confirm, dive into these documents and confirm whether or not they are indeed relevant based on the themes that you see. And this is a way to attack the document population based on these predictive ranks. So here I've got really high ranking documents. So these are supposed to be responsive documents based on my positive and negative examples, and using the cluster wheel and the themes around those highly ranked documents to confirm that whether or not they are indeed responsive, or are they false positives? Are they actually non-responsive? And being able to bulk code these clusters when you look at these themes and say, look, this this set of themes, even though it's the documents in it are highly ranked, this has nothing to do with my case. So I'm going to bulk tag them as non-responsive. And that way you can do some bulk tagging using the focus feature and the cluster wheel, and then use those decisions that you've made, those tagging decisions at a bulk level, and feed those back into your CAML classifier and use those to retrain your classifier. So you can see how easy it is to train the classifier, um, and how easy it is to get to the likely to be responsive documents as quickly as possible. So we just give you this very quick, efficient, easy way to use something that's very powerful, which is our supervised machine learning capability. Now, you can run this entire process inside of BrainSpace, and we recommend that you do that for investigative type cases where heavy review is not required. Large review teams are not required. It's just a handful of individuals. You can use this to manage. You can use BrainSpace to manage that entire process inside of our interface. But let's say you want to use the CAML classifier and the CAML workflow for larger cases like litigation cases. You can do that. We give you that capability as well. So instead of creating a tag within BrainSpace and then associating that tag to a classifier, you can connect to a tag in Relativity. So here I've gone back to the tag management screen, and I've clicked on connect tags. And here you can see BrainSpace goes out and it queries the Relativity workspace tied to this particular data set or project in BrainSpace. And it returns all of the single choice, yes, no, and multi-choice fields in your Relativity workspace. And you can decide which field you want to connect to. So again, these are Relativity fields that you're connecting to. And when I click connect, you'll see that connected field show up in my list. There'll be a little connected icon here. You'll see the choices that were created in Relativity, and then we'll pull over, or give you the ability to pull over all of the choices that were made for this particular tag in Relativity. So once you connect to that Relativity tag, you can pull in all of the choices or all the coding decisions from Relativity into BrainSpace. And now I can use this connected tag, this connected Relativity tag, to build the same CAML classifier or build a CAML classifier. So if I go back to the classification screen, here's an example of one we've already built. And you can see what's different about a CAML classifier that is using a relativity connected tag is you'll see that information up here. You'll see connected tag, the name of the tag. Um, you'll see that there are a couple of new options here at the top. One is a pull tag option. So anytime you're ready to train the model and you want to pull in all the coding decisions from Relativity before you kick off a training round, you can do that on demand just by clicking pull tag. It will pull all the most up to date real time decisions that are in relativity, it will make sure that all of those coding decisions for that connected tag get pulled into BrainSpace automatically and presented to you in the form of a training round here at the bottom. And you can simply just click on Train Now to use those coding decisions from relativity to train your BrainSpace Camel classifier. You can also set this whole process up of running the training, pulling the coding decisions from relativity, running the training round in BrainSpace, and feeding back the predictive ranks to relativity. You can set that whole process I just described up to run on a schedule automatically. And the way we do that is by clicking on the scheduler icon, click on reoccurring, and then indicate how often we want this camel classifier to run, and then what time of day, and then what's the first date we want it to run. You set all that information up, click save, and then whatever frequency and time of day you specified, and let's say you're going to run this on a daily basis at 9 p.m. at night Eastern time. Um, so at 9 o'clock, now that I've set this up to run, starting today, all the coding decisions that get made throughout the day in relativity for a particular case, all those coding decisions for this connected tag will get pulled in at 9 p.m. at night automatically into BrainSpace. BrainSpace will automatically run a training round on those coding decisions. It will update the predictive ranks for all the remaining documents in your relativity workspace, and it will feed those predictive ranks back into relativity, and then you can use those predictive ranks to prioritize document review. So if you're not going to use supervised machine learning to auto code documents, you can certainly use the Camel classifier and the Camel workflow with relativity to prioritize documents for review so that you get to or batch out for review the most likely to be responsive documents first based on a predictive rank. And we even recommend that you only batch out a day's worth of review until you feel like you've got your Camel classifier trained and stable to a point where it doesn't require any additional training. So what you would do is you batch out a day's worth of review. You'd use those that day's worth of coding decisions, feed those automatically back into BrainSpace using the scheduler, and it will train the model and feed back ranks. Then you use those ranks to batch out another day's worth of review. And at the end of the second day, those ranks then, based on the scheduler you set up, or the coding decisions, will automatically get fed back into BrainSpace. And that process will just keep repeating itself on a daily basis. And then once you feel comfortable with the ranks that have been assigned and you feel comfortable that no additional training is required, you can then turn off the scheduler and then batch out the remaining documents using the predictive rank that we feed back into relativity. So it's a great way to prioritize linear review for larger matters, second requests, litigation matters. But again, if it's an investigation, even if it's a government investigation and you're trying to just get ahead of it and you want to understand what the facts of the case might be, you can run this entire Camel classifier workflow inside the BrainSpace interface. So for investigations, we recommend you do that. For litigations, for second requests, for those larger cases, we recommend you use the Camel to relativity workflow and set that up to run on an automated basis. This concludes our demonstration. For additional information on how to use any of our features, including step-by-step instructions, please visit our new online user documentation portal called BrainSpace Support Station at docs.brainspace.com. If you are a new BrainSpace user or do not have access to this site, please contact BrainSpace Technical Support at support@brainspace.com and request access. Thank you.